Welcome. My name's Dave Huntingford. I work for a company called CSR, Cambridge Silicon Radio. It's headquartered in the UK, and we're this year cracked the $1 billion mark, which we're very proud of. So moving into the slides, what I'd like to talk about today is an introduction to our product called Surf Fusion. And this is a product where we're really trying to bring highly accurate indoor location without any additional infrastructure being required installing in the buildings. So we use Wi-Fi signals, MEMS sensors, and GNSS signals if they're available. And it enables indoor positioning. We run at about 5 to 10 meters of accuracy 95% of the time. So it's a completely crowdsourced system. It operates without any user interaction to calibrate or learn indoor Wi-Fi fingerprinting data. And combining all this together allows you to roll out multiple services for indoor, indoor applications. So the point about fusing data together is that it also improves outdoor performance. So generally, if you're walking around between skyscraper buildings, you tend to see some pushing around of GPS because of multipath signals. And by using the MEMS sensors in the phone, accelerometer, gyroscope, we can start to reduce those position errors. So the platform itself is capable of additionally supporting Bluetooth Smart, the Japanese beaconing system IMES. We also can support NextNav signals, which are GPS signals transmitted on 900 meg license spectrum. And that has very good penetration into buildings. We also support Boeing XGPS, which is based on Iridium satellites, and many other signals that we can receive. So when we combine together this multiplicity of data, we really start to get good quality indoor positioning and navigation at a 1 Hertz rate. So key point, we don't need any new infrastructure installing, and it's completely self-learning and self-calibrating. So the architecture is a client-server-based system. It's a cloud-based system. And on the handset side, in our chipset, we support all 4 methods of GNSS, so GPS, GLONASS, Baidu, and Galileo. We have a MEMS gateway on board that provides information such as user context, orientation, placement of the handset on the body. We can tell if it's on the belt, in the hand, to the head. And we also have a technology called pedestrian dead reckoning. So we use the motion detecting sensors to be able to track where you're walking, the size of your footsteps, and it's completely self-calibrating. We also have an extra radio channel that we can use for sniffing, and we can receive Wi-Fi signals, GSM, Iridium, Boeing XGPS, various different signals. So if we have the right antenna and RF chain in front, we can combine all this data to really bring location to an indoor environment. And the reason we think that this has a lot of value is because once you start to bring that outdoor experience people have today with GPS, generally GPS is getting to be good enough. People use Google Maps, you're driving with it, it can take you to the building you need. But as soon as you go indoors, you don't really get that same experience of quality 1 Hertz navigation to take you to the location. So we see it as there's a demand for this technology. Most of the ecosystem pieces are coming into play. You know, Google has 11,000 odd locations mapped indoors already. And you know, you zoom in, the map opens, it's indoors, but the location isn't that good. And so that's the technology challenge, but we're looking to solve with this product. Okay, so of course, well, how well does it work? So this is a beta trial that we're running in Japan. And you can see here that as you walk through this central Tokyo station, there's a shopping mall there, and we start at the bottom and walk towards the top. And we're typically about, in this test, 3 to 5 meters of accuracy. Maximum error here was about 7 meters. And the key point about this plot is that the first fix was taken completely with Wi-Fi. And this data was crowdsourced by our system. So the first few times through the building, you're very dependent on pedestrian dead reckoning, and you're building up an indoor Wi-Fi database. Then as it evolves with a couple of people walking through the building, the quality of the positioning starts to come up to this type of level. So the little red flags are the truth markers, and the track is the path that Fusion created. So the pedestrian dead reckoning technology using the MEMS sensors really creates this smooth trajectory, and then the Wi-Fi brings the corrections to keep the position errors under control. So we're really pleased with this level of performance. And in this example, we're showing 3 different walkthroughs of same station, different route. And you can see that the results there were very repeatable. So we see that once this technology really starts to arrive in the handset, then it really enables things like augmented reality. You know, the big thing that this does is because you have a good quality position and you have orientation data for the handset, you now really know what the person's looking at with the camera, and you have an accurate location. So the delivery of the content can be much more targeted towards the user, instead of a kind of big uncertainty indoors and you're not quite sure what the person's looking at. So far we've been talking about what we term location creation. This is a system, client-server based, that's all about generating very accurate indoor positioning. And in the next couple of slides, we're going to talk about what we call location consumption. So these are the type of services that can be layered on top to put this location capability to use. So we have a cloud-hosted platform, and we see a couple of really key areas we're looking at. So consumer proximity marketing, it's kind of a retail play, enterprise for device management and security. And this could be where maybe documents open when you're within a known geofence area, and when you leave that area, you're not allowed to view that document. And obviously that needs very high quality positioning underpinning it, and it needs to be reliable and repeatable. Asset tracking is a very obvious example. You know, today, generally asset tracking works well outdoors. It works okay indoors if you install new infrastructure, but there isn't really a solution today for trying to do indoor asset tracking without installing new infrastructure. So we think this really comes together to solve that challenge. So looking a little bit deeper at some of these applications, mobile geofencing, certainly healthcare is an area where security is really key. And we see very good examples of where you should only be able to open the patient's record when you're near the patient. And maybe the patient has a Bluetooth low energy tag on their wrist, and that beacon effectively moves with the asset. And that can be coped with our cloud-based server, in that we can understand what's a portable Bluetooth low energy hotspot versus a fixed asset tag you know, that you may be doing positioning to within the building. Specials material tracking, situational awareness. I mean, a lot of this is really, I would say, relatively obvious what the applications are. What we're bringing to market is a highly accurate location technology that's going to underpin the development of these solutions. So thanks for your time. And we're going to be running a demo at the back, and we have a demo on our stand in Hall 6 where you can see walk around and check out our indoor navigation. Thank you.